LangChain's generative AI projects. I've been coding for 5 years now, and if I could go back and give my younger self just one thing, it would be this. Not a framework, not a tool, this way of structuring code. It gives you clarity on where everything goes, and once you have that, everything else becomes easier. Every project, every team, and every stack. This is the one thing that changed how I build software. Quick heads up. This is mid to advanced level Python, alright? So I'm going to assume that you are comfortable with classes, inheritance, and basic object-oriented programming. If you are not there yet, go learn that first, then come back. Seriously, this video isn't going anywhere. I'll also link some resources in the description. So the 3 layers in code. Think of it like building 3 rings. The valuable stuff lives in the center, protected. The replaceable stuff lives on the outside. Domain at center, application in the middle, infrastructure on the outside. So let's write each one. Starting off with the domain. The domain layer is the heart. Your entities, your domain services, and your port definitions all live here. We have a message with a role, content, and a timestamp. We have a conversation that holds messages and knows how to get the last 10 for the LLM. And look what's not on there. Not OpenAI, no databases, no HTTP. The domain doesn't even know that the internet exists. It's living its best life. These are pure Python objects that represent your problem domain. Then we have ports. An LLM port that says, give me messages, I'll give you a response. A conversation repository that says, I can save and find conversations. That's it. No mention who's behind them. The domain layer has 0 external dependencies, only Python standard library and your own code, and maybe Pydantic for data consistency. This is the core of your application, and it's the core of this architecture. Your business rules live here, pure functions and pure logic. If you are building a health tech product, the thresholds for what counts as a false positive live in the domain. If you are building a ticketing system, the rules for an email prioritization live in the domain. If you are building a recommendation engine, the matching logic lives in the domain. These are the things that make your application, not just a wrapper around somebody else's API, which, if we are honest, this is what most generative AI projects are right now. Moving into the application layer. So this contains your use cases, the specific things that your application can do. Think of it this way. Most people on LinkedIn post about workflows. Each workflow would be a use case. In most applications, you are going to have 20, 30, maybe 50 use cases. Just imagine the order that this gives to your application. Having 30 use cases without proper wiring, calling infrastructure, and your database here and there. That would be a complete mess. If you look at send message use case, it receives an LLM port and the conversation repository port in the constructor. Then the execute method does 5 things. Get or create a conversation, add the user message, get a response from the LLM through the port, and the assistant response, and save. That's it. 3 key things about the application layer. First, it orchestrates. It doesn't implement. The use case coordinates between domain objects and ports, but it doesn't know how the LLM generates text or how the database saves data. Someone put it perfectly, a use case should read like a recipe. Load this, do that, and save the result. If it reads like a novel, the domain model is too anemic, meaning that ideally the domain should have the core logic, not the application. Second, each use case gets its own class. No more God class, meaning one bloated service with 30 methods, like chatbot service. Send message use case, summarize document use case, search knowledge base use case. Each one focused, each one independently testable. This sounds more like files, but each file is tiny, and does exactly one thing. Third, dependencies are injected. The use case receives the dependencies in the constructor, and it doesn't create an OpenAI client, it doesn't connect to MongoDB. It receives something that implements LLM port, and something that implements conversation repository port. It doesn't know or care what's behind them. The LLM could be a guy in a basement typing really fast. The use case wouldn't even know the difference. That's called dependency injection. And it's the mechanism that makes all this work. It sounds fancy. It's just passing arguments to a constructor. Welcome to software engineering. And moving into the last layer, the infrastructure. The infra is where the real world lives. Your adapters live there. Infrastructure adapters implement the ports. You might already have LLM adapters. Here's a repository adapter. The MongoDB adapter implements the conversation repository port. The save method converts the domain conversation into a raw dictionary with ID and the timestamps. The find by ID method does the reverse, takes a MongoDB document and builds a domain conversation from it. And here's the key. The MongoDB adapter has its own way of representing data. That's different from the domain conversation object. The adapter handles the mapping between the two. This is intentional. Your domain entities serve the business. Your persistence entities serves the database. One class, one job. The moment you put the database annotations in your domain model, your domain is coupled to your storage. And here's the beautiful part for testing. An in-memory conversation repository that implements the same port. Just a dictionary. Save stores it. Find looks it up. No database needed. The final piece is the composition root, the one place where you wire everything together. Create app. It reads an environment variable to decide which LLM adapter to use. It creates the MongoDB repository. It wires them into the use case. And we are done. Now, look at what we have. If we want to switch from OpenAI to Claude, we change one line in main, and your domain and use cases don't change at all. Want to test your use case? We inject the in-memory repository and a fake LLM. No real APIs and no real database, so no money spent. We can add a CLI alongside your REST API. We can create a new driving adapter. All your use cases stay exactly the same. That's the beauty. If you want a new LLM provider, you create one new adapter and everything else is untouched. And how does it relate to other patterns? You'll hear people mention maybe clean architecture and onion architecture. They are cousins, let's say. Same core idea, dependencies point inward. Business logic doesn't know about the outside world. The differences are mostly naming and how many layers they draw on the diagram. Hexagonal is the most practical for most teams. If you understand this, you understand all the others. So let's talk about the testing payoff. One of the biggest wins with this architecture is testing. Testing stops being the thing you avoid. The architecture makes it the easy path. The domain layer, no mocks, no wiring, pure logic, done in milliseconds. Use cases you test with fake adapters, no real LLM, no real database, so no money spent. Only the adapters need to touch real infrastructure. And system tests, end-to-end, those you use sparingly, thus spending a bit of money. The test pyramid naturally emerges from the architecture. You don't enforce it. The structure makes fast tests the path of least resistance. For once, the path of least resistance is also the right path. That never happens in this industry. And honestly, I've been able to design entire applications this way. You define the actors involved, the objects that play the core of the application, and what actions they need to perform. The use cases. Then I fake the databases, I fake the other providers, and use test doubles for all the infrastructure. So no real APIs, no real database. When you use generative AI applications, it gets weird mocking the LLMs. But you write all the use cases and the models, test everything, and now the business logic works. No database needed, no API calls. Then the infrastructure just falls into place. The contract tells you exactly what to build. You fulfill it, and it works as designed. A while ago, I read that book and just talked about this topic. So, a production system's entire persistence layer was swapped from Flask plus SQL Alchemy plus Postgres to CLI plus CSV files. Zero changes to domain or service layer. Only adapters changed. That's not theory. That's production software at scale. So just with that example, I believe that it's quite clear how powerful this architecture can be with this type of refactorings. All of this works just if you enforce the boundaries. A rule that's only in someone's head will be broken by the next developer who doesn't know that it exists. In Python, we can use tools like import linter or write custom checks that verify our domain layer never imports from infrastructure. Some languages have libraries where you can literally write a test that says, no class in domain might depend or any class in the adapter, and it runs on the continuous integration. 3 lines of code, and violations will be caught automatically. No code review, vigilance required. The point is, if your architecture makes testing hard, you have the wrong architecture. And if your architecture isn't enforced automatically, it's only a matter of time before someone breaks it. And moving towards the AI coding angle. Now, there's a dimension to this that didn't exist 10 years ago. AI coding assistants. As I did more projects and leaned harder on AI coding assistants, not writing code myself manually, rather defining strict boundaries, become essential. So I could go back and forth with my AI coding assistant, let's say Claude Code, trusting it more, and knowing that we are all going to follow that structure that beforehand we decided. The code always looks the same. Think about what happens when you give an AI a well-structured hexagonal codebase versus a messy one. With hexagonal architecture, you can just tell your AI assistant, create a new adapter, LLM port using Gemini, and it has a clear contract to implement. It knows exactly where the file goes, and it knows it can import anything from the domain into infrastructure beyond the port interface. The boundaries are super explicit. With a messy codebase, you say add Gemini, and the AI has to guess where it goes, what to import, what patterns you follow. 3 pull requests later, your main branch looks like a crime scene. Going faster means not thinking about structure as well. It's always the same. I already know where each part goes. This also hinders you a lot on your day-to-day when you don't have it, meaning this folder structure, because every time you switch projects, you need to look at the different code structures. So it just makes you way slower at the beginning. Otherwise, if it's always like that, so no new surprises. The same structure every project, and with AI coding assistants writing the boilerplate, the setup cost is nearly zero compared to what it was before. There's also a concept called Schema-first development that fits naturally with this. You define your entities, ports first, the contracts, and then you or your AI assistant fills in the implementations. So when you give an AI a precise interface to implement, it goes from creative generation, where it has to make hundreds of decisions, to constraint satisfaction, where the boundaries are already defined. AI is much better at filling its contracts than guessing it from scratch, so the rate of error drops dramatically. I can assess it. I've been able to design an application by defining the actors involved, the objects that play the core, and what actions they need to perform. Just by saying, the user writes a ticket. This ticket gets replied by an AI. Being able to fake all the infrastructure, write the use case, and models, test everything, and be sure that the business logic works. Then the infrastructure comes later. When you work this way with AI, you are basically pair programming with a very capable junior who needs clear instructions. The architecture is those clear instructions. But also there are some gray areas that we need to talk about. You know, most videos about hexagonal architecture stop here. Everything's perfect, everything's clean, use it for everything, and that's it. But that's not real. So here are the honest takes that nobody talks about. Starting off with when it's overkill. If you are spending more than 2 or 3 days on a project, use hexagonal architecture. No, but really, if you need to invest a certain amount of time in a project, it's absolutely worth the upfront cost, especially with AI making the boilerplate super easy to write. We are not going to lie ourselves. But for a utility script, for a quick automation, just write the script and move on. Also, framework friction. This is a real gray area. If you are using a framework like LangFuse or Phoenix, your code is already coupled to their ecosystem. I've recommended this to colleagues who are deep into LangChain ecosystem and they couldn't create clean code that wasn't really coupled to it. I built a large application with LangGraph, trying to integrate that within Hexagonal architecture while keeping it clean. You end up doing workarounds to not break the core. So it's a gray area, knowing whether, based on the nature of the framework, it should be inside in the infrastructure or you should create another folder entirely. In this case, you have to decide, do you want the comfort of that framework or do you really want to build clean code that's going to be everlasting and not tied to any dependency? Because when you are tied to an ecosystem, you are batching their updates, relying on the release cycle. Your code is only as stable as their decisions. And also, this is a really good question. Where do prompts live? This is another question that nobody has a clean answer for. Prompts are like training data in machine learning. Prompts change. You rewrite them and you tune them, and they also drift. So, should it be part of the infrastructure or maybe part of the domain because it's business logic? Ask me where I put prompts in my last 3 projects and you'll get 3 different answers. This can create some ambiguity. I've seen teams go both ways. I believe that there is no consensus yet. And moving towards the scaling problem. When a project grows large, hexagonal architecture is great. But when it grows super large, you start to mix concerns. For example, the entities get mixed between each other. The same happens for the ports. The same happens for the adapters. And you need to start separating the domain from the infrastructure for each use case. It's a bit strange, alright? You need to start creating bounded context within itself. Because otherwise, looking and scanning code bases becomes really tiring. The ports folder become a large mess of ports that are not grouped by any domain. Just imagine the whole use cases from any application put in the ports folder. It becomes quite big. So, what about mapping? How much is too much? Every time data crosses a boundary from the API to the use case, from the use case to a database, you need to decide how to transform it. You have a few options, alright? No mapping. The use case is the same model everywhere. Your domain conversation goes straight into a controller and to a database. It's fast to implement, but now your domain model carries HTTP annotations, database logic, everything. Any change ripples everywhere. Then we have two-way mapping. Each boundary has its own model. The API has chat requests, the domain has conversation. The database has the raw document format. More code, but changes in one layer don't affect the others. And the last one is full mapping. Input and output models at every port. The use case doesn't receive a domain object. It creates a send message command. Maximum decoupling, but also maximum code and maximum boilerplate. So my take, it would be to mix strategies based on the boundary. Use full mapping at the API layer when things change a lot. Use simpler mapping for internal boundaries that are stable. The question isn't whether to map, it's where the pain of mapping is worth the gain of coupling. Nobody in these videos talks about shortcuts. There's a great argument for taking them consciously, okay? The sin isn't taking a shortcut, rather it's taking one without understanding the cost. A startup building an MVP might reasonably skip the mapping between web and domain models. A production system handling medical data, I believe that should not. The key is to make a deliberate decision, documented, with an understanding of when the shortcut should be reversed. That's infinitely better than accidental shortcuts that accumulate because nobody realized that the architecture was eroding. The enemy of good architecture isn't shortcuts, it's unconscious shortcuts. And 3 things that I keep hearing that are wrong. Hexagonal architecture equals domain-driven design. There are, let's say, orthogonal. Hexagonal is how you structure your code. DDD is how you model your business, alright? They complement each other but are independent in this regard. The hexagon is the domain. Wrong. The hexagon contains both the application logic and the domain logic. Also, more mapping between layers means more waste. The mapping cost is paid once. The benefit compounds over years, meaning that you have independence, testability, and the ability to change layers without touching others. So, wrapping up, here's the bigger picture. Development speed, confidence in the codebase, and maintenance. Remember, the walls from part 1 that you couldn't touch without everything collapsing, now every wall that we have in our building is removable. Remember the example from the book that we talked before? 0 changes to a domain or service layer when they swap the entire infrastructure stack. That's what this architecture buys you. My client code bases have complex logic, but it's super clean. Compare that to looking at spaghetti code that's legacy and coupled. Maybe you need to change some database and you are going to break the program for sure. Because it can have testing if it's highly coupled. You can do a progressive migration, replacing it piece by piece, but it's completely coupled, even that falls apart, alright? Working with clients, there's nothing better than pitching the way that you coded the proof of concept, wanting to evolve into an MVP, and having the tech lead of the client team give you the reason in front of the CTO, telling you that this is the proper way to code, and this code base is really good, meaning that feels really great. You are always going to have the support of somebody who is technical, even if it's from a client team, because they know that you use the proper architecture. It's a universal language that you can speak with any other technical person. So wrapping up, I would say that the best architecture is the one that lets you deliver today and change tomorrow. For complex, long-lived systems with multiple integration points, that's hexagonal. For a weekend script, It's not, just know the difference. But when you use it, the pattern is simple. Your domain is at the center, pure and protected. Your use cases orchestrating through injected dependencies. Your infrastructure implementing the contracts that your domain defines. Dependencies point inward, always. In part 3, I open a real production project and walk through it file by file. You'll see how all this plays out in a codebase that actually ships. Plus, I'll release the full starter repo for free. Domain, application, and infrastructure all wired up and ready to clone and for you to build on. If you try this in your own projects, drop a comment. I'll read all of them. And if you got value from this video, subscribing helps. I'll see you on part 3.